Okay, question 3 is talking about using infrared heating lamps and a harmful effect of infrared waves. Okay, if you put your hand next to these infrared heating lamps, then what would happen? Okay, your skin would go all crispy like a piece of crispy bacon, right? Okay, so that's the danger, is the potential for skin burns, right? Skin burns. You also get visible light produced, and two similar properties of visible light and infrared waves. There's lots that you could have had here, right? Okay, they're both part of the electromagnetic spectrum. Okay, and because of that, they've both got the same speed, so you could write the same speed, or you could even write down what the speed is. It's 3 times 10 to the 8 meters per second in a vacuum. They're both transverse waves. They can both travel through a vacuum because they don't need particles to be able to travel. And they both transfer energy, and they can also be reflected and refracted. Okay. Right, so lots of different ones that you could have had there. Now, two differences between the properties of visible light and infrared waves. It doesn't say the uses, right? So if you start talking about the uses of infrared and the uses of visible light, you're not going to score the marks here because you're not answering the question, right? Okay, so infrared has got a longer wavelength than visible light. And because it's got a longer wavelength, it's going to have a lower frequency than visible light as well. We need to calculate the time taken for infrared waves to reach the car. So we've been given a velocity and we've been given a displacement, right? Okay, so we know that velocity is displacement over time. Now, are we allowed to use this formula? Yes, we are, because it's a constant velocity, so it's okay for us to use this formula. That's a good thing to check, right? This is the formula for constant velocity. If we've got an acceleration, not allowed to use this formula, right? So then we're going to rearrange that, which is T is S over V. So we've got 1.5, okay, divided by 3 times 10 to the 8. And if you tap that into a calculator, hopefully it will give you your answer in standard form, because otherwise it's a lot of zeros to count, right? And it's absolutely okay to give our answer in standard form, okay? Don't forget the unit. Okay, it's time, so the units are seconds. The paint takes less time to harden because it's getting heated by the infrared radiation, right? But white paint would take more time than black paint, right? So explain why. So we need the idea that the black paint is a really good absorber, okay? So it's a really good absorber of... Now, we've got to be careful here, right? Because if it's a good absorber, we need to link how that is going to reduce the time for the paint to dry. So just saying that black is a good absorber of light, black's a good absorber, that's not enough, right? We need to talk about black being you can either talk about it being a good absorber of heat, okay, or you could talk about it being a good absorber of energy, because it's the heat or the energy that's going to allow the paint to dry and harden. Okay. All right, that's the end of question 3. How do I do it again? It's